Assalamualaikum and greeting for everyone. Today me and my group will present the tradition of food industry. Before we go to the slide, let me introduce you our member. First of all, my name is Nur Fatin binti Jafar and this is my friends Feni Betrisha Palatos, Alexandra Dudi and Nur Syahira binti Musa. Let's take a look of the content of our presentation. The first one is introduction, item in titration, theory, methodology, result, example, conclusion, and reference. So, for the introduction, the titration is the technique commonly used in the food industry for various purposes, primarily in quality control and to determine the concentration of specific component in food products. The process involves the controlled addition of titrant to a simple solution until the reaction between the titrant and the analyte is complete. This allows to determination of the analyte concentration or to present of the certain properties in these products. So there is two types of picture that we can see for this slide. The first one is burette and the second one is conical flask. So the burette function is to hold the standard solution of concentration that we know, and conical flask is to hold the simple that we don't know the concentration. Before we proceed to the concept of acid-base titration, there is few important steps that we should know before we do the titration, which is the term in the titration. The first one is titrant, the reactant that will react with standard solution from the burette of non-concentration. The second one is analyte, a simple which is the concentration to determine. And the third one is endpoint, an organic dye that determined in the endpoint shown by the changing color. Same with the indicator, an organic dye that determined in the endpoint shown by the color changing. And the last one is equivalent points, the point which an equivalent or stoichiometric amount of titrant is added to analyze the base of stoichiometric H.
So moving on, I'm Alexandra and I'm going to explain the theory behind titration in food industry. So, titration is a laboratory technique in chemistry used to determine the concentration of a substance in a solution. It involves the controlled addition of a solution with the known concentration, which is the titrant, to a solution with the unknown concentration, which is the analyte, until the reaction between the two is complete. The point at which the reaction is stoichiometrically balanced is known as the equivalent point, and it is often indicated by an observable change in the properties of the solution, such as a color change in an indicator or a change in the pH. There are many types of titration, but we are going to focus more on the acid-base titration. So there are 4 types of acid-base titration. Number 1 is we got the strong acid and strong base titration, which require any type of indicator. The second one is strong acid and weak base titration, which is require a methyl orange indicator. And thirdly, we got weak acid and strong base titration, which is the phenolphthalein as the indicator. And lastly, weak acid and weak base, which there are no suitable indicator for it because the reaction between the weak acid and weak base is very slow in nature that there are no steep rise occurs. Hence, there are no indicator can be used to detect the endpoint. So moving on with the calculation for acid-base titration. First, we need to calculate the moles of the titrant, which is the molarity multiplied with the volume in liters. Next is to determine the stoichiometry. We need to write the balanced chemical equation for the reaction between the analyte and the titrant, and also to determine the mole ratio between the titrant and the analyte. Next is to calculate the moles of analyte, which is the formula is moles of titrant multiplied with the mole ratio. Next, we need to calculate the concentration of the analyte, which is the formula is moles of analyte divided with the volume of analyte in liters. Next, adjust for dilution. If the analyte solution was diluted before the titration, we need to adjust the concentration using the diluted equation, which is M1 V1 equals to M2 V2. And lastly, we need to calculate the average volume of the titrant if performing multiple titration.
Hi, I'm Shaya. So next is our methodology. So for our methodology, we're using an experiment which is the fruit juice sample. Since in the fruit juice they contain some citric acid, which is a common acid can be found in the citrus fruit, and the concentration in the fruit juice is quite interesting in the food industry. So the purpose for our methodology is to determine the citric acid content in the fruit juice sample. And before we proceed to the procedure, we're preparing the apparatus and the chemical itself. So for our apparatus, we got the burette, pipette, retort stand, conical flask, funnel, and the whiter. As for our chemicals, we got the phenolphthalein indicator and the 0.1 molar of sodium hydroxide, distilled water, and the fruit juice. So before we proceed with the procedure of the titration, we have to standardize the sodium hydroxide itself first, which we titrate the solution of hydroxide solution with the known quantity of the oxalic acid or the potassium hydrogen palette. And afterward, we prepare the sample preparation, which dilute the fruit juice sample to the proper concentration, and we combine it thoroughly. So after we have standardized the sodium hydroxide solution and we got the sample preparation, then we can proceed to the titration procedure itself. So first, we have to pipette a volume of 10 ml of the diluted fruit juice into a conical flask. And then we add a few drops of the selected indicator, which is the phenolphthalein, to the diluted fruit juice. And we fill the burette with the sodium hydroxide solution. And afterward, we pipette the 10 ml of the diluted fruit juice into a 250 ml of conical flask, and then we added 2 or 3 drops of phenolphthalein as an indicator. The sample in the conical flask was titrated with the sodium hydroxide solution from the burette will be slowly while shaking the flask until the indicator color changes. And for the color change for the phenolphthalein, the solution changed color from the colorless to a faint pink, and afterward the reading at the end point of the titration were recorded. And we record the volume of the sodium hydroxide solution that have been used to titrate and diluted the fruit juice sample at the end point. And then lastly, we have to repeat this 2 or 3 times, and we record all the readings into the table.
Hi, my name is Fanny Beatriza Palitus, and I will be presenting the example of results of titration in food industry. In titrating the diluted fruit juice with phenolphthalein as the indicator, the endpoint is reached when the clear solution transitions into light pink color. This change indicates the neutralization of citric acid in the fruit juice by the sodium hydroxide solution. All the data obtained from the experiments are recorded in Table 1. Based on the data of titration between diluted fruit juice with sodium hydroxide solution, the volume of sodium hydroxide that was used during the first titration is 21.5 ml, for the second titration is 20.8 ml, while the third titration is 22 ml. So the calculated average volume of sodium hydroxide used to titrate the diluted fruit juice is 21.4 ml. In order to determine the concentration of citric acid contained in the fruit juice, first we need to determine the number of moles of sodium hydroxide. To determine the number of moles of sodium hydroxide, the molarity of 0.1 is multiplied by the volume of 0.0214 liter, so the mole of sodium hydroxide is calculated as 0.00214 mole. The next step involves determining the moles of citric acid by using the balanced chemical equation of the reaction between sodium hydroxide and citric acid. From this balanced equation, we are able to establish the mole ratio between sodium hydroxide and citric acid, which is 1 mole of citric acid is equivalent to 3 moles of sodium hydroxide. By dividing the moles of sodium hydroxide by 3, we are able to determine the number of moles of citric acid, which is 0.000713 mole. The third step is to determine the concentration of citric acid contained in a fruit juice. The formula for a concentration is moles of solute divided by volume of solution. In this case, divide the moles of citric acid by the total volume of the diluted fruit juice solution to obtain the concentration of citric acid, which in this case is 0.0713 molar. In conclusion, we can conclude that titration can be applied in food industry to determine pH content in food to ensure optimal acidity, to determine unknown solution concentrations in food processing, as well as to ensure product quality and meet regulatory standards.
So these are the references that we use in this video. And with that, thank you for watching this video.